Okay, welcome to this Science Revision video. In this one we're going to look at enzymes and digestion. Now some of this stuff we've covered in a previous video, but I want to extend it here to look how enzymes particularly have their influence in the digestive system. Okay, so some of the first bit you may have seen before, but let's press on. Now we mentioned in a previous video that molecules are made up of simple units. So sugars, for example our glucose here, are combined together to form bigger carbohydrates, for example starch and glycogen. Fatty acids and glycerol, okay, they combine to form fats, oils. Amino acids, they build up proteins. So we talked about enzymes actually having the opposite effect of breaking these things down. So enzymes are what we call biological catalysts. They speed up the rate of chemical reactions going on inside living things. So what are the features of these enzymes? Enzymes are globular proteins. They're large molecules and they're made up of proteins. Every enzyme has an area called its active site, or we've also referred to this as a binding site. Enzymes are specific, so an enzyme will only catalyze one reaction. For example, in the mouth you've got amylase. Amylase acts on starches in your mouth to break them down to sugars, and that's all that enzyme does. So enzymes are specific. Enzymes are affected by temperature and pH, and hopefully you've had a chance to have a go at a previous video at the temperature investigation, and also you've done some research about what's called denaturing. Right, now naming them, we said this, that enzymes are named by adding the ASE to substrate molecule being acted upon. For example, sucrase is the enzyme and that works on the substrate sucrose, OSE, ASE. Lipase, the enzyme, works on lipose, the substrate. So we've got ASE, enzyme, OSE, substrate. But as in most biological things, always exceptions, and a few enzymes are known by common names, example pepsin and trypsin. Let's look here at the enzyme action. The substrate is what's being acted upon, so sucrose in this case. The enzyme acts upon the substrate, in this case it's sucrase. The product is what formed, and here we've got glucose and fructose. Right, let's look now at some of the enzymes around the human body. First of all, in your mouth you've got the salivary gland. The salivary gland produces amylase, hence the ending, which breaks down carbohydrates such as starch into simple sugars, e.g. glucose. Quite specific, huh? Down here in the stomach we've got protease being produced, and this breaks down proteins into amino acids. Interesting about this is that the protease is very pH specific. So in here you've got also acid being produced that makes the stomach quite acidic, and those are optimum conditions for protease action. Now this here very important organ called the pancreas. Now the pancreas produces loads of enzymes including amylase, breaks down carbohydrates and sugars, protease, breaks down proteins and amino acids, lipase, breaks down fats to fatty acids and glycerol. Can you see how these are the reverse of what we talked about earlier? We talked earlier about building blocks. Well, these are breaking down. Down here you've got the small intestine, a very, very, very long organ called the small intestine, and this again produces, yes you guessed it, enzymes. So we've got here amylase again, protease and lipase, and you should now know what substrates they work on: carbohydrates, proteins, fats. Now another thing, maltase, which is thought to be produced by the walls of the small intestine here, okay, converts a disaccharide maltose, which is formed by the action of amylase on starch, into simple sugar glucose. So it's a two-stage process. The amylase breaks the starch down, okay, into maltose. The maltase breaks the maltose down into glucose. So you can see there it's like a two-phase process, isn't it? Okay? Right. Well, I hope you've enjoyed that video, and for more free revision videos please go to my site www.sciencerevisionvideo.com. Thanks for watching. Bye for now.